Problem 7. Find the derivative of sine hyperbolic of cosine hyperbolic of x. So notice it is chain rule once again. So you set u to be cosine hyperbolic. Then derivative of u with respect to x is sine hyperbolic of x. So derivative of sine hyperbolic of cosine hyperbolic with respect to x is d by du of sine hyperbolic u times du dx. Derivative of sine hyperbolic is simply cosine hyperbolic and du dx is simply sine hyperbolic. In other words, cosine hyperbolic of cosine hyperbolic times sine hyperbolic. So let's look at that. Cosine hyperbolic of cosine hyperbolic of x times sine hyperbolic of x. Okay, correct. Next, find the derivative of e raised to t secant hyperbolic t. This calls for product rule. Derivative of the first as it is, e raised to t, second as it is, plus first factor as it is, derivative of secant hyperbolic is negative secant hyperbolic t tan hyperbolic. Alright, so this gets me secant hyperbolic and e to the t are common factors. So e to the t secant hyperbolic times 1 minus tan hyperbolic. Notice secant hyperbolic is nothing but 1 over cosine. That's incorrect. 1 over cosine hyperbolic. So this should be e to the t times 1 minus tan hyperbolic t over cosine hyperbolic t. Alright. I have to fix that. It should be cosine hyperbolic in the bottom. Okay. So secant hyperbolic is 1 over cosine hyperbolic. Next, find the derivative of e to the 2 cosine hyperbolic 6x. E to the 2 cosine hyperbolic 6x. So all of that is u. We are going to use chain rule, you see. So what's the derivative of this? That's 2. That's sine hyperbolic 6x. And then don't forget chain rule times 6. So in all it's a 12 sine hyperbolic 6x. Derivative of e to anything is itself as long as you use the chain rule. So eventually you get 12 sine hyperbolic of 6x times e to the 2 cosine hyperbolic of 6x. Correct. Next, integral. Integral negative 4 to 4 of cosine hyperbolic x over 1 plus sine hyperbolic squared x. Look, this calls for substitution. Let's call u to be sine hyperbolic squared x. Then du is derivative cosine hyperbolic x dx. That's the numerator. So that's good, fantastic. When x is 4, u is sine hyperbolic 4. When x is negative 4, u is sine hyperbolic negative 4, which itself is negative sine hyperbolic 4 because as we saw earlier in our lectures, sine hyperbolic is an odd function, that is negative comes out. Okay, so this integral is nothing but negative sine hyperbolic 4 to sine hyperbolic 4. All of that is du. All of this is 1 plus u squared. Well, integral of 1 plus u squared is tan inverse u. Tan inverse u with these limits. So tan inverse of sine hyperbolic 4 minus tan inverse of negative sine hyperbolic 4. Again, tan inverse is an odd function, so the negative comes out, this becomes plus. So 2 times tan inverse of sine hyperbolic 4. Notice this is tan inverse and this is sine hyperbolic. Okay, so hyperbolic is in the argument but not outside here. So answer is 2 times tan inverse. Tan inverse is what we call arctan of sine hyperbolic of 4. Good. Next problem. Calculate the integral. Integral negative 1/3 to 1/3. Integral of 1 over 1 plus x squared. Okay, so this is the last page. So let me go over here. Negative 1/3 to 1/3, 1 over 1 minus x squared. Well, integral of 1 over 1 minus x squared is tan hyperbolic inverse. So don't forget, integral of 1 over 1 plus u squared is tan inverse, whereas minus gives me tan hyperbolic inverse. I'm simply going to apply it to these limits. Keep in mind, tan hyperbolic inverse is also an odd function, so the negative comes out. Okay. Once that comes out, twice tan hyperbolic inverse of 1/3. Twice tan hyperbolic inverse of 1/3. Okay, let's see whether it accepts it. Yeah. So that's it. That completes our problem. So this completes section 6-7. Again, let me remind you, all my lectures follow closely the text by James Stewart on calculus. Okay. Until then,